Chapter 8, Section 2 is about trig ratios, and a trig ratio is a ratio of two sides of a right triangle. Ratio of two sides of a right triangle. And by definition, sine is the opposite side over the hypotenuse. Cosine is the adjacent side over the hypotenuse, and tangent is the opposite side over the adjacent side. And what all that means, we have a right triangle over here. There's our right triangle. If this is the angle we are talking about, we have three different sides. The hypotenuse is always the side that's across from the right angle. If this is the angle we're talking about, the side that is across the triangle is the opposite side. And then this one right here is the adjacent side, or right next to it. So hypotenuse is across from the angle. Hypotenuse is across from the right angle. The opposite side is the one that's across from the angle that we're looking at. And the adjacent side is the side that's next to the angle we're talking about. And there's a memory trick. It's called SOHCAHTOA. SOHCAHTOA, that's a way to help you remember sine, cosine, and tangent. This stands for sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Our first example, we want the sine of J. So here's the angle. Sine is opposite over hypotenuse. So we do the opposite side over the hypotenuse. So that is 60 divided by 61. And as a decimal, 60 divided by 61 is 0.98. Cosine of J, cosine is the c, adjacent over hypotenuse. Well, if this is the angle, I don't know if you can see, this is the angle, that's the adjacent side over the hypotenuse. So we will have 11 over 61. 11 divided by 61 is 0.18. And the last one, or tangent of K, is the next one. Now we're talking about this angle. Opposite over adjacent. The opposite side is the 11. The adjacent side is the 60. So you have 11 over 60. And if we divide that, again, we get 0.18. And the last one on this example is the tangent of J. This is the angle. Opposite side is 60. Adjacent is 11. So you have 60 divided by 11, and that becomes 5.45. Now we move on to the next angle, or next triangle, and you might want to write SOHCAHTOA up here, just as a reminder. Cosine is the c, adjacent over hypotenuse. This is our angle right here. 24 is adjacent, hypotenuse is 25. 24 divided by 25 is 0.96. The next one, we're looking at a different angle this time. Tangent of B, tangent is the TOA, opposite over adjacent. So 24 over 7. And grabbing my calculator, 24 divided by 7 is right about 3.43. Sine of B is the SOH, S-O-H. 24 is the opposite. 25 is the hypotenuse. So 24 over 25 is 0.96. And the last one, sine of A. Again, sine is the SOH, opposite over hypotenuse. So that will become 7 over the hypotenuse, which is 25. And if you divide that, 7 divided by 25, it is 0.28. The back side, we are asked to use the calculator to find the trig ratio. So the sine of 52, you're going to hit your sine key, 52, and we're asked to round to the nearest hundredth. So that becomes 0.79. Cosine of 19, there's your cosine key, 19, round that to 0.95. Tangent of 65, 2.14. Tangent of 11 is 0.19. Sine of 62 is 0.88. And cosine of 30 is 0.87. Now these next 6 examples, we're going to use these ratios to find some side lengths. We are asked to find BC, and I'm going to put an X right there. This is the angle that we know. If this is the angle that we're talking about, this is the opposite side, and this is the adjacent side. Opposite over adjacent is the TOA. Opposite over adjacent is TOA, tangent. So what we do is the tangent of 15 equals 10.2 over x. Now the quickest way to do these, if you ever have the variable on the bottom of a fraction, is switch these two, and you will have x equals 10.2 over the tangent of 15. So we enter that into our calculator, 10.2 divided by the tangent of 15, and we get 38. So BC is 38. Remember, the first one's always the worst. It's always the hardest. Let's try a couple more. Next one, we are asked to find QR. So I'm going to put my X right there. If this is the angle that we know, that is the opposite side, and this is the hypotenuse. Opposite over hypotenuse is sine. So we do the sine of 63 equals x over 12.9. Sine is opposite over hypotenuse. And solving this one, we can just multiply these two things. 12.9 times the sine of 63 is 11.49. I'm going to round that off to 11.5. And we use sine on that one because we had the opposite side and the hypotenuse. Example C, we're trying to find ST. And if this is the angle that we know, this is the hypotenuse. This is the adjacent side. Adjacent over hypotenuse is the cosine, or the c. So we will have cosine of 42 equals x over 9.5. And again, with that one, you can just multiply. 9.5 times the cosine of 42 is 7.06. And we used cosine because we had the adjacent side and the hypotenuse. Example D, we're trying to find FD. So I'm going to put the X right there. This is the angle. This is the adjacent side. This is the hypotenuse. Adjacent over hypotenuse is cosine. So we have cosine of 39 equals 20 over x. Quickest way to solve these is just to switch those two. And you have x equals 20 divided by the cosine of 39. 20 divided by the cosine of 39 becomes 25.7. The next example, we are asked to find BC. This is the angle that we know. That is the opposite side. And this is the adjacent side. Opposite over adjacent is tangent. TOA, opposite over adjacent. So we have the tangent of 18 equals 12 over x. Since the variable's on the bottom, you switch those two. And you have x equals 12 divided by the tangent of 18. 12 divided by the tangent of 18 ends up being 36.9. I'm going to round it off to 37. And JL, we're asked to find that one, which is x. If this is the angle that we know, that is the opposite over hypotenuse. Opposite over hypotenuse is the SO, which is sine. So you have sine of 27 equals x over 13.6. You can just multiply that. 13.6 times the sine of 27, and that ends up being, I'm going to round it to 6.2. And then the next example, the world's steepest cog railway is in Switzerland. The steepest section makes an angle that is 25.6 feet, or 25.6 degrees. So right here is 25.6, and it rises 0.9 kilometers. And we are asked to find how long is that section of the railway. Well, this is the opposite side. This is where that tram would go, the railroad car would go, which is your hypotenuse. So if we know the opposite side and the hypotenuse, that's the sine, or so. So we will have the sine of 25.6 equals 0.9 over x. Quickest way to solve those is to switch those two, and that becomes x equals 0.9 over the sine of 25.6, and dividing that, 0.9 sine of 25.6 That ends up being 0.388. It doesn't seem, we don't multiply that, sorry about that, we divide. 0.9 divided by sine of 25.6 looks a little better. The answer then ends up being 2.08 kilometers. And then the last thing is our special right triangles. 45, 45 right triangles has, you should know the ratio of the sides. In case you forgot, it's 1, 1, square root of 2. And then we had a 30, 60 right triangle. And if this is the 60, the big angle, this is the 30, the small angle. 1 is the shortest side, 2 is the hypotenuse, and this side is the square root of 3. So the first one we are asked to do is cosine of 45, and if you want to, it might not be a bad idea to write down SOHCAHTOA. Cosine of 45, this is our 45-degree angle. You have adjacent over hypotenuse. So you will have 1 over square root of 2. If you remember, you can't leave that square root in the denominator. So that moves to the numerator. And then you take whatever number is on the denominator and it comes outside of the square root sign. And we'll have a couple of them that we have to do like that, not all of them. Tangent of 45 is opposite over adjacent, 1 over 1, which is 1. And sine of 45, sine is the SO, opposite over hypotenuse is 1 over the square root of 2, which becomes square root of 2 over 2. Sine of 30, this is the 30-degree angle. Sine is the SO, opposite over hypotenuse is 1/2. Cosine of 30, cosine is CA, adjacent over hypotenuse, which is square root of 3 over 2. Tangent of 30, tangent is the TOA, opposite over adjacent, 1 over square root of 3. Can't leave it like that. So that becomes square root of 3 over 3. This number moves to the top, and then whatever the number was inside the square root comes outside. Sine of 60, sine is the SO, so it's opposite over hypotenuse, square root of 3 over 2. Cosine of 60 is the CA, adjacent over hypotenuse, so 1 over 2. And tangent of 60, tangent is TOA, opposite over adjacent, so that will be square root of 3 over 1, which is the square root of 3.